Hi, so we're going to look at an example hydrate problem. So I have some data here. We have our empty crucible, the mass of the hydrate kind of teared out just like we did it in our lab, and the mass of the crucible plus the anhydrate after our heating. And then the hydrate formula we're using here, my unknown, is aluminum chloride, and we don't know how many waters. And so when I'm talking about anhydrate in this example, I'm using aluminum chloride, but yours is going to be magnesium sulfate or whatever other compound that you used. So the goal here is to find two things. We need to find the mole of the aluminum hydrate, the anhydrate, aluminum chloride, and the mole of the water. And then I'll take the mole of the water, put it over the mole of the anhydrate. That'll hopefully give me somewhat close to a whole number that I can put there for a ratio. So let's dive in. First, we're going to try to find the mole of the water. And so I talked about this in class, but just to reiterate, the hydrate is what we start with in our crucible. It turns into the anhydrate. That's going to be what's after we heat it up. What do we lose? We lost water. So the water came out. What we need to find is grams of anhydrate. We don't really need to find grams of hydrate. Grams of anhydrate, and we need to find grams of water because if we have grams, we use molar mass to turn them into moles. And so let's find our grams of water. So we know the difference between the hydrate and the anhydrate is water. And so we can take our crucible plus hydrate would be 15.807 plus 1.254, and that would give us 7 plus 1.254, 17.061 grams. That would be crucible plus hydrate. And now if we have our crucible plus anhydrate, the difference in those two is going to be water, because if we have crucible plus hydrate, crucible plus anhydrate, the difference is still water. So I can subtract the crucible plus the anhydrate, which is 16.499 crucible plus anhydrate, and that is going to give me minus 16.499, 0.562 grams of water. So find grams of water first. Great. That's our grams of water. Next, we can find the moles of water. Now to find the moles of water first, we got to make a pit stop to find the molar mass. So for molar mass with H2O, we have two H's. Each H is 1.01. We have one oxygen. Each oxygen is 16. These numbers might look a little bit different from your periodic table. This is from the numbers in my head periodic table. So we get 18.02 gram per mole. Remember that if we have this per here, that is like the horizontal line of a fraction. So we could write 18.02 gram over 1 mole, or we could write 1 mole over 18.02 gram. And so that per is acting as the horizontal line of a fraction, or you can think about it also as 18.02 gram equals 1 mole. And then just remember that if two things are equal to each other, we can put them on top of each other in a fraction. So however you want to think about the conversions, that's kind of how we can look at it. So if I have 0.562 grams of water and I want the grams to go away and I want to get moles, think about which one of those fractions I'll need to use. I'm going to put the grams on the bottom and the moles on the top. Don't put gram per mole on the bottom because remember, that per is actually the same as this as the line. So these two things are the same. So we don't want to put 2 units on the bottom, just 1 unit on each side. The grams will cancel and we're left with moles of water. So divided by 18.02 and we get 0.031187. I don't like to round these numbers because we want to try to get a whole number as best we can at the end. And if we round too much now, think about rounding. How much is a mole? A mole is a really big amount of molecules. So rounding a really big amount of molecules is going to cause my formula to be a little bit off. So we don't round them until the very end. So I actually just keep everything in my calculator for that. Okay, so we have our moles of water, which is great. So our next step is going to be, let's talk about the anhydrate. That's the aluminum chloride for me. That's my anhydrate. So let's find the mass of the anhydrate first. And you can do this in whatever order you want. Find grams of AlCl3. And so in the lab, we were just calling it anhydrate because you had multiple trials of different things, but you can at this point, you can stop writing anhydrate and you can actually write in what you're talking about, MgSO4 or NiSO4 or whatever it is that you're doing. So how do I find the mass of anhydrate? So I have the crucible plus anhydrate, that's 16.499. So you can write that down, 16.499 grams. That's crucible plus anhydrate. And then we have just the crucible. So we can just subtract out the crucible to get the anhydrate by itself. If I subtract a crucible, I get anhydrate by itself. So 15.807. If I subtract that out, minus 15.807 grams of just crucible. So crucible plus anhydrate minus crucible gives me just anhydrate. So I get 0.692 grams of anhydrate. And remember, my anhydrate is aluminum chloride. Your anhydrate is going to be a little bit different. So that's going to be the grams of the anhydrate. Next, we need to find the moles of aluminum chloride, which is my anhydrate. So we're going to use the molar mass again. So if we're looking at molar mass for aluminum chloride, we have 1 aluminum at 26.98. We have 3 chlorines at 35.45 each. And we can just add that up. I do it in my calculator, 26.98 plus 3 times 35.45, close parentheses, 133.33 gram per mole. And again, we can write that in different ways. So I'm not going to write that out for you this time, but you can write it out in different ways, however you want to do your molar masses. So here's my water example, and you can write your new molar mass in whatever way makes sense for you. So we'll take our grams of our anhydrate, which is aluminum chloride, and then we'll use the molar mass. I'm going to put the number that comes in front of the gram on the bottom to cancel the grams and 1 mole on the top. My grams will cancel. I'm left with moles of aluminum chloride. So 0.692 divided by 133.33. And I get 0.0051913 moles of my anhydrate aluminum chloride. And again, I'll just remind myself that's the anhydrate. You should start using those formulas. So that'll be your moles of your anhydrate. So now remember, our whole goal was this. So let me copy paste this down here. So our hydrate formula has 2 things. We got water and we got the anhydrate. So now we have the moles of both. So let's figure out what that number is, that X. So moles of water over moles of the anhydrate, which for us is aluminum chloride. For you is going to be a little bit different. Again, I keep saying that just because I don't want to see aluminum chloride in your post labs. So what's our moles of water? 0.003118756 moles of water. And again, I leave all these numbers because we're trying our best to get a whole number. So maybe for some of y'all who are not getting whole numbers, maybe you round it a little too much. Because when we round moles, we're actually rounding a whole lot of atoms and molecules. So give yourself lots and lots of numbers if you can. Have the patience for it, and it'll help make your answer maybe a better whole number. 0.0519013. And I get a nice whole number here. I get 6.0090 something something, and we can round that to 6. So my X is 6. So my formula is going to be aluminum chloride 6H2O, which would be called aluminum chloride hexahydrate. So there will be my final nice answer for my formula. I hope that this helped. Replace all your numbers with all my numbers with your numbers. Replace your substances and my substances in this example. Remember, this is just an example, but your math should work in the exact same way. Hope that was helpful.